Hello, everyone. I'm Alex Bularca. I'm a front-end architect at Everymatrix. Um, we're a company that operates in the iGaming industry, so basically we deal a lot with online gambling, such as sports betting or casino games. Recently, we've delved into the realm of single-page web apps rather than having desktop apps and mobile apps. We've started building reactive web apps, and we've had a good experience. But recently, we've started investigating progressive web apps, and that's what I'm going to talk to you today about. So, what are progressive web apps? Well, a progressive web app is an application that embraces progressive enhancement to provide the user with an app-like experience by supporting offline mode by being very performant in bad environments such as on 3G connections or edge connections. And it basically maintains the low friction between the app and the user at every moment. Progressive apps, because they follow the progressive enhancement pattern, they are supercharged in modern browsers that provide all of the features that they need. They load fast on a slow network, and of course, they use service workers and push notifications to provide re-engagement to your users. So why are we doing this exactly? Well, in the past, there's been a lot of options for creating so-called hybrid apps, such as Cordova, Ionic, recently React Native, and Adobe Air for those who remember it. But none of them have actually managed to provide the low friction experience that the web has. And I'll talk to you about that in a second. So what are the problems with them? Well, they're not easily discoverable. You can't just click a link and get to the app. You need to go to an app store. You need to download the app. You need to accept its permissions. That involves quite a lot of steps. Second of all, you can't get the fast iteration that you get on the web. You can't just upload your files to a web server and they just get served to your users. You need to go through the process of getting your new version approved into a store. And they have complex packaging. As I said, you can't upload to a server. You need to go through the packaging of your various platforms. And we all know how big of a pain iOS and Android are. And furthermore, on average, a mobile user uses around 25 apps in a single month. But they navigate over 100 websites. And there's a company called Fixu that has something called the cost per install index. And this is basically a chart that plots how much companies are paying to get the user to install their app on various platforms. So it's about $3.50 on Android and almost $2 on iOS. So for every user that installs your app, you pay that amount. Multiply that by the amount of users you want to get, you get a high amount. And installs have a cost. In a consumer mobile app, you lose 20% of your users for every step in your funnel. So, for example, for a standard mobile app, if the user has to go to the store, you lose 20% of your users. The user has to find your app in the store, 20% more users lost. Then they have to click install, 20% more users. They have to accept permissions, they have to wait 3 minutes for your app to download, and then they finally get to use the app. That's almost half, if not more, of your users lost before they actually even manage to get to content. That's a lot of users, and that's a lot of friction, at least in my book. So what can we do about it? Well, we can create progressive web apps. And progressive web apps are created by using web app manifests. They need to have service workers in order to function. They allow the user to add a home screen, and they provide push notifications for re-engagement. Okay, so how does a web app manifest look like? And what is it? Well, it's a JSON file that allows you to describe what your app does and what resources it has so that the browser knows how to deal with it. Here's a sample of a web app manifest. It's basically, as I said, a JSON file that describes what icons your app provides, what its name is, how to start the thing, and how to display it. Okay, now we get app install banners. They look something in the likes of this, the lines of this. This is a bit blurry, but you get the point. There's a banner on the bottom part that basically asks the user to install the app. The browser does this for us automatically. And there are a couple of conditions for it to happen. Those are, you have to have a web app manifest. The browser can't treat your app as an app if it doesn't know it's an app and what resources it has. It has to be served over HTTPS. That's a prerequisite for also running service workers, so keep that in mind. It has to have a valid service worker registered so that you can provide offline caching. And it has to be visited at least twice in the last, with 5 minutes between the visits, so that you actually get the app install banner. Okay, so what are service workers? Service worker, well, basically what a service worker is a JavaScript script that runs in the background of your application off of the main thread. And it allows you to catch network requests and perform offline caching, actually respond to requests without actually hitting the network with content generated inside of the service worker. It also allows you to improve performance a lot because you basically don't hit the network every single time. You can also pre-cache assets, even though they're not actually requested at the time. And they allow you to control the application cache via JavaScript. There's been another option for doing offline caching before. It was called app cache, but it has severe limitations. It was a declarative approach that basically allowed you, the developer, to specify what files to cache, but it broke down really easy if you basically broke any of its assumptions. Wait, wrong button. Okay, so what's the basic architecture of a service worker? Well, when you register, you first need to register a service worker, and there's an API for that. Then, if registration was successful, it is then executed, and it basically receives an install event. In the install event, you can actually pre-cache all of your application shell, so that whenever the user actually requests a resource, she doesn't have to go out to the network to get it. After the script is installed, then it gets an activate event. And that's a very good place to basically put any cleanup code that clears old caches, for example. Let's say you updated your assets, created a new cache, you don't need the old ones, and we don't really want to kill the user's machine by filling their hard drive with caches. And after everything after that has happened, then the service worker actually has control over all of the requests that the user does after it has been activated. And how do you register a service worker? Well, I wasn't planning on showing you that much code, and it's a bit blurry. But I guess we'll deal with it. So you basically, first we need to do a feature check, because we've mentioned we're doing progressive enhancements. So if we don't support it, we don't use it. Then we actually call navigator service worker register with the path to the service worker and an optional scope. So basically, the part of the website that should be controlled by this particular service worker. Mine controls /swtest. So anything under swtest is basically controlled by my service worker. Anything else won't be. So I won't get called if somebody hits, for example, /foo. And then we can just console log that the registration was successful or failed. And this happens on your main thread. Any other code that runs inside of the service worker happens off thread, but this is the only piece of code that needs to run on the main thread, main UI thread, to be specific. Okay, so how do we cache things? We cache things by basically, first we can do it on install. As I mentioned, we can pre-cache stuff. We can have a list of files, maybe generated at build time. And there are tools to do that for service workers. So we can have a list of assets generated at build time. And we can just add those to the cache. We can create a cache, wait until, add everything, and wait until everything is saved. The cache storage interface represents the storage for cache objects. It is backed by IndexedDB, where it's supported, of course. And yeah. And then we can wait for a fetch event. When a fetch event happens, in this example at least, whenever a fetch event happens, God, this is blurry. My screen is great. It's great, yeah. Whenever a fetch event happens, we have the option of responding with the cache, with the cached version for that particular request. And we basically have an event respond with that can then call caches match event request. And event request is an object with the request path, and yeah. Okay, so it's not really useful to only reply with the cache because you never hit the network. So what we can do, we can actually, as I mentioned, we can make a custom reply. So we can say event respond with a new response that just sends an HTML text. That may be useful if you want to do some off UI thread processing for, I don't know, rendering React components inside of a service worker. That's been attempted, and it has a 50-50 success rate. Okay. You can also do a fetch call. A fetch call basically goes out to the network and actually does the request. And of course, you can match a fallback URL. So in case you don't have, you're offline, and the user made a request for, made an AJAX request, and you can't show it, you can basically reply with a fallback. Okay, so let's go for a cache-first approach. How do we do that? Well, we need to listen for the fetch event, and then we need to respond to it. And we first try to match the cache. Pardon me. If we can't match the cache, we then try to fetch the actual request from the interwebs, and then we try to cache it, because we may not have it. The user, we may have done an AJAX request to a resource that changes often. So we then try to cache it and respond with whatever we got back from the network. Now, I haven't mentioned this, but all of the service worker APIs that are synchronous work with promises by default. So what you see there is basically a simple promise chain that does whatever I need to do it to do. Okay, I actually skipped a couple of slides and I want to go back to them. Okay, so coming back to progressive web apps. Progressive web apps are basically single-page applications built on a couple of principles. First, they should be progressive. They should work for every user, regardless of browser choice. They should be responsive. They should fit any form factor. We should get out of the trend of building mobile and the separate desktop sites. They should be connectivity independent. They should work offline. They should take advantage of caches, which I've shown earlier, so that we can provide at least a partial experience of what the user would normally get if they're connected. So for an app that relies heavily on internet content, you could just have the application shell, so basically the navigation and most of the UI cached locally and available offline, and notify the user gracefully that you don't have connectivity. They should be app-like. They should use the app shell model to provide app-style navigations and interactions. And actually, if you use standalone mode, which I'll show a bit later, you need to provide your own navigations because you don't get browser controls. They should be discoverable, and this is something that relates to the low-friction environment of the web. It should be easy for a user to discover your applications via search engines, via sharing links with friends. And it should be a one-click experience to actually get to your app. They should be re-engageable. They should make use of push notifications in order for them to engage with the user. And of course, they should be installable. User should be able to keep the apps they find useful on their home screen. And they should be linkable so that you can share URLs. And here's an example of re-engagement. You basically have a web app on the left side. it's in a browser, it runs in a browser, but then the user decides to add it to the home screen. And then the user has the app on the home screen, they want to interact with it again, and then they open it. And the app provides a splash screen. This is one of the features that have been actually Google Chrome implements it right now, and it's in work in other browsers. But this is one of the features that provide you with a way to provide an almost app-like experience to your users. Okay, let's move forward to the demo. Okay, so I'm going to be showing you an application. It's not written by me. It's written by a guy called Nolan Lawson. And I considered writing my own, but then I found this, and it's a Pokedex. It's basically an application for managing Pokemon. And I found that way too fun. So let me just switch over to my screen sharing really fast. And I hope you see, oh, this is way too big. There we go. Okay, this is basically from my phone shared to my laptop. So this might be a bit choppy. I'm going to be sorry for that. So let's go to Pokedex.org. Now, when I go to Pokedex.org, I immediately get, there we go. I immediately get asked to add it to my home screen because I've been here before. The browser knows that I may want to re-engage with it. And I'm going to do just that. I'm going to add it to my home screen, and let's browse a bit through it. It's just your standard web application that shows information about Pokemon. We can search. Okay, let's search Pokemon. Let's say Loris. There we go, Slowpoke. Okay, so we have Slowpoke here. We know that he's really, really, really slow. You can't really find him in the wild anymore because he's so slow that none of them ever reappeared. Okay, so this is basically the web app. But now I can close this. I can kill it. I don't need it anymore. I can go to my home screen where I have a link to my application. And if I click it, I'm basically taken to a full screen version of the same app. This is a problem because I actually did the hack to get the add to home screen banner. Okay. And I can do the same things that I could do. I can open Charmander, I can see information about him. So it works exactly the same. We have a very good experience, fluid animations, so on and so forth. Okay. But what happens if I take it offline? What happens if I lose connectivity? Let's put my phone in airplane mode. Okay, so no more Wi-Fi, no more data. Let's kill the app again. And let's see what happens. I'm going to get a splash screen again. And then the application loads. Everything is offline. Everything is cached. That is because the service worker is running in the background. And it has cached all of my requests on the initial render. So everything I see here is cached data. I could have optionally, actually, it could have optionally notified the user. Wait, my phone locked. It could have optionally notified the user that it went offline, and it could notify the user that he went online again and wants to refresh the caches, for example. That's very useful for applications like newsreaders. You could download the top 10 articles offline every time the user comes to your app, and then you could show him the content that you last downloaded. So the user always gets content and is able to engage with your app. Because I go to sites like Hacker News, and if I'm not online, I can't read the content. But if I only download a small subset, there's enough for me to enjoy while I'm offline. Okay, so let's take a wee bit of a look inside of the code of this particular application. It's on GitHub, it's open source. I'll provide the link after this is over. And I full screened it on the other screen. Let's try again. Okay, so as I said, it's written by Nolan Lawson. It's a very simple app. It's written in jQuery. It doesn't do much. But what we're actually interested in is what its web manifest looks like. So let's take a look. It's what you'd expect, actually. It just defines the name of the app, a bunch of icons that you've already seen on my home screen. The type of display, this could be standalone, which is what you've seen before. It's standalone, but it also has the headers. the standard operating system notification bar and whatnot. It could be full screen. That's useful for a game, for example. Or it could be browser, when you don't want to implement your own controls and you want to rely on the browser for everything. You can also define orientation. It could be so basically you can fix it in an orientation, be it portrait or landscape. And you need to define the start URL. And this one needs to be offline cached by default. So if you don't cache the start URL, you're not going to get the app install banner. And you're not actually going to be able to add it to home screen. This launcher through is useful if you want to track users that have launched your app from the home screen, for example. And that's useful. OK, so this is the app manifest. Pretty standard stuff. Let's see what he does in his service workers. These are buried deep inside of the JS folder. I almost lost video again. So let's see how his service worker looks like. It's a simple file. So the service worker, it basically requires a bunch of stuff. He uses Webpack to generate it. And it basically requires a bunch of stuff, but that's not what we care about. We care about the static content, which he caches, which are the icons, the manifest, the main JavaScript files, so basically the application shell, and the launch URL. And he also caches a couple of other files in development, basically unminified stuff. And then, on install, what he does, he opens his cache. He called it a Pokedex static plus version. And he adds everything inside of the static content array. Then he sets an active version and does a couple of other things to parse the version and whatnot. We don't care about that right now. You can also define an onMessage, and you can message the service worker from your main UI thread. So you can basically have support for things like pre-rendering React.js, as I mentioned. And that's a nice feature. OK, and then on activate, he basically clears all the old caches. This is basically what this block of code does. He basically gets every cache that he has. He goes through all of them. If they match Pokedex static and are not the current version, he deletes it. And that's about it. And on fetch, of course, he tries to match the cache. If he can't, he fetches from the network. And that's basically all that it takes to build a progressive web app. OK, so let's go back to the slides. I actually finished way earlier than I expected to. I have a reference table here with a couple of articles that have been inspiration to me and a couple of projects on GitHub. For example, SW precache is a script that allows you to generate a service worker that precaches your assets at build time. And SW toolbox that gives you a couple of tools so that you can build service workers for cache-first scenarios, network-first scenarios, or whatever else you need. And with that, thank you. And if you have questions, please go ahead. Yes, you can do push notifications. There's a new API that basically leverages service workers to get requests from push notification servers and pop them to the user screen. I haven't demoed that because it's not 100% stable yet, the API. But it's coming. It has support in Chrome. Firefox is working on it, as far as I know. Edge have listed it under consideration. And Safari, well, they've shown no interest, as Safari does nowadays, the new IE. Any other questions? The browser support for service workers. So basically, Chrome, Opera, and Firefox all support service workers. Edge has shown interest. And Safari has also showed interest via an engineer's 5-year plan. In terms of app manifests, Chrome and Firefox support, and Opera support it. Edge has shown interest. It's the same story all over again. So, yeah. This works for Android because Safari hasn't said anything yet. Whenever Apple decides they want to implement it in WebKit, it's going to work in Safari as well. but until then, you can't, unfortunately. No, because it basically uses WebKit and JS Core. Any other questions? Um, I'm planning on using it for the back office application at every matrix. So, so basically allowing our users to at least cache the application shell, the navigation, and most of the content. Not all of it, because some of it is real time. And I also plan to suggest to our front-end team to use it for our clients' websites, so that they can basically, for example, a website that only has casino games doesn't really update that often. So you can basically cache everything, well, except the casino games, which are not built by us. But you can cache everything else and give the user an offline experience. Go ahead. Yeah. Yeah. Well, what you can do is you can have your service worker catch all of the requests that basically write content. Yeah, you take camera pictures and you want to upload them online to, I don't know, let's say you're building the Google Photos app, right? Okay, what you can do is basically you can tell your service to catch all of the requests that basically upload the photos to the internet. And if it's online, you can basically put them in a cache. You just dump them in a cache. And then uh, a cache that you name. Basically use the cache API, the cache storage API, to create a new cache. So let's say cache open photos, right? And you create a new cache. You dump all the photos inside of the cache, right? And when the service worker detects that it's online again, it can just do the request asynchronously. Uh, there isn't a defined limit yet. It's not infinite, of course. As far as I remember from Upcache, and I think it shares the limitations, it's about 150 megs. But that's plenty. No, you can't abuse that cache because basically the service worker is executed inside of a sandboxed environment and only it has access to it. You can't actually inject content into a service worker. Yeah, you can abuse it. You can abuse it and you shouldn't. It's also important to note that the user can revoke access to your service worker. So if your service worker misbehaves, it uses too much cache, it is too network active, it's too chatty, it kills the battery, the user can disable your service worker. And they actually get notified that your service worker is abusing something, and they can disable it. So keep that in mind. It's the same for push notifications and for app install banners. If you have app install banners that happen too fast, because you can actually have some control over app install banners. You can stop them, you can show them later if they've been shown at least once. But if you're being noisy, the user will again be able to kill your notifications. And I don't know if has someone used the Facebook app recently on Android, the Facebook mobile site. You have. Have you noticed that they send push notifications? You have. Yeah, on the browser. That's what I mean. They send notifications on the browser. Those are. Yeah, they do, because Chrome supports service workers as well, Chrome for desktop. They're using service workers today to push notifications to you on desktop and mobile Android. Because I've actually inspected my service workers, there's, let me just show you that, if I can remember the URL. Okay, Chrome / I need a colon. Worker internals. So basically there's Chrome service worker internals, and you can basically see all of the service workers that you have running. So I have one for Airhorner, which is an app, a demo app. I have one from Google Inbox. This also sends push notifications, by the way. More actually from Inbox. I have a demo from React Worker, which is actually the project that I mentioned that tries to render React inside of a service worker. Voice Memos, which is the app that I had screenshots on in the slides, and Facebook.com, where push notifications come from. And you can actually inspect these. You can go inside of the service worker, but not from here, from DevTools. And you can actually inspect the service workers, debug it as you would a normal JavaScript file. No, basically they're short-lived processes. They only work as long as you actually use them. So basically, they install, they activate, and then they die. They stop. And then whenever you do a network request, they then get started again, they process the request, and they get killed. And the push notification API added support for incoming requests as well that activate the script shows the notification, and then it dies again. So they're very short-lived. They don't run in the background forever. You need to take that into consideration as well. You basically can name caches, right? And what I forgot to mention is that whenever you change something a bit inside of a service worker script, the browser basically re-downloads it and it reinitializes it and reactivates it. So you can just change the version of your cache. So you can do caches open v1, caches open v2, and then you can just switch assets like that. And that's an easy way to manage asset versioning, especially if you're pre-caching. Other questions? It doesn't require permissions to run. But if you, for example, want to use the voice API, it's going to ask you permissions as a normal browser would. If you want to use location, it's going to do the same. So basically, it follows the same browser model. Service workers in itself don't do much. Actually, they don't do nothing. They don't do anything. Double negative. As with the browser, it won't request permissions for the voice API, for example, every time you need it. It will store because it's basically a browser tab, and it behaves exactly like a browser tab, just that it doesn't have controls if you don't want them to. So it's basically the same thing. Yes. Yes, the service is going to be started up. It's going to be started up. It's going to receive the notification. It's going to do its thing to show it, and then it's going to be killed again. The same for network requests. You as the author can't actually delete it. You can deregister it. You cannot register it, actually, and it will be removed. It won't be started if it's not registered. Other questions? I'll take that as a no. If you have any more questions, you'll find me at the Every Matrix booth near the exit on the right. Thank you very much for your questions and for your time. And with that, I think lunch is waiting outside, or it should be soon. Thank you, guys and girls.